Often when we're talking about sets, it's helpful to define something called the universal set. And for us, this is going to be the set of all elements involved in a specific discussion. So when I talk about the universal set, I'm talking about a specific example or specific thing I'm working on. We will use capital U usually to represent this set. So if you see capital U from now on, it's probably representing the universal set. And this is just so that when I'm, for example, solving an equation and I'm talking about the solution set, so all the different solutions to the equation, I don't have to wonder like, well, are elephants in this set? Probably not, because my universal set would most likely be the set of all real numbers or the set of all complex numbers when I'm solving an equation. So limiting ourselves to a specific set, a specific universal set in a discussion, means that we don't have to worry about a bunch of crazy things. We just can focus in on what we want. Along with this, if we have a universal set, we can talk about the complement of a set. So the complement of a set A is the set of all elements in the universal set that are not in A. Okay, this is everybody except the elements in A, is A complement, or the complement of A. We'll write A complement to mean A complement. So that's an A with either a single quote or an apostrophe or a prime symbol or whatever, however you recognize that symbol, that's A complement. And if we want to get very fancy about it, we can write the set builder definition of A complement. This is a set of all X such that X is in the universal set and X is not a member of A. Okay, so the complement is everyone in the universal set that is not in A. I also want to talk about Venn diagrams because they're really helpful in this area. So I want to draw a Venn diagram. I want to draw a Venn diagram for these sets. I've got a universal set, and then I have my set A. Okay, so here's my universal set. And then inside of here, what I'm going to do is draw a circle. Okay, and this is my set A. And now what I do is I put all of the elements in the universal set somewhere in this rectangle. So this rectangle is representing my universal set, all the things that should be in there. So I need to put in there 1, 2, 3, 4, 5, 6. But then also I want this picture, this Venn diagram, to represent the set A, and it should have these elements 2, 3, and 5 in it. So I'm going to start there. And in general, when you're working with a Venn diagram, you always want to start kind of in the middle or kind of in the most restrictive place. So 2, 3, and 5 belong inside of that universal set and also inside of A. So I put them in the circle for A. Now I just need to ask myself, well, what don't I have up here yet? I've got 2, 3, and 5, but I still need 1 somewhere. I need 4 somewhere, and I need 6 somewhere. So my universal set had 1, 2, 3, 4, 5, 6 in it, and I see there 1, 2, 3, 4, 5, 6. My set A had 2, 3, 5 in it. I see 2, 3, 5. And this gives me a good chance to say, what does this set A complement? Well, it's everything that's in the universal set that's not an A. I can look up here and say, well, 1, 4, and 6 belong in that set. But I can also look at my Venn diagram and notice those are the numbers outside of this circle A, but in the universal set. So A complement can kind of be thought of as everything outside of this circle A if I have a picture for a Venn diagram. So A complement, everything not an A. Okay, just one more example here quick. Here's someone already drew a Venn diagram for me. It obviously wasn't me using this board because it looks pretty nice. And then it asks, what are the following sets? Well, let's look. Oops, I'd rather have black here. The universal set is just everyone in this rectangle anywhere. So 1, 7, 5, 6, 3, 4, 2, 10, 9. Now remember, a set doesn't care what order its elements are in, so this is a fine way to write this. Sometimes your homework will ask you, hey, put them in order. We can do that if we really want. I don't know that I do, but I will. 1, 2, 3, 4, 5, 6, 7, 9, 10. Okay, so my universal set is all the natural numbers less than or equal to 10 except 8, I guess. Now, let's look at what's in set A. That's a bad place for A. We will put it over here. In the set A, it looks like I have 2, 4, 9, and 10. Okay, that set A is 2, 4, 9, 10. And then this set A complement is everyone in the universal set except those guys. So again, I could either look at this set, look at that set, and say what's missing. Or for A complement, I can look at my circle for A, since I have a nice Venn diagram, look for everything outside of that. Everything outside of the circle for A is 1, 5, 1, 3, 5, 6, 7. And then if I look at A and A complement, they should give me everybody. So I have 1, 2, 3, 4, 5, 6, 7, 9, 10. That is what was in my universal set. So I feel pretty good. I found A and A complement.